Welcome to The Explainer. Today, we are diving into something you might not think about when you see a rocket launch, but it's one of the most critical parts of space travel: planetary protection. And really, it all boils down to one massive question.
Yeah, that one. This question is at the absolute heart of every single mission we send out into the solar system. I mean, as we push further and further out there, we have to be incredibly careful that we're exploring responsibly, and not accidentally wiping out the very life we're hoping to find.
So, to get this right, we're basically fighting contamination on two fronts. First up is what's called forward contamination. Think of it like us tracking mud into a pristine, clean room. We're trying to avoid bringing our super tough little Earth microbes to a place like Mars. Then there's backward contamination. And this is the one you've definitely seen in the movies, right? It's the risk of bringing something unknown, maybe something hazardous, back home to Earth.
Okay, so what are we actually doing about this? I mean, it's not like it's the Wild West out there in space. The entire effort to keep planets clean all starts with a really important international treaty.
And here it is, the granddaddy of all space law, the Outer Space Treaty. And get this, it was put together way back in 1967, right at the peak of the space race. It's the legal bedrock for everything we do in space, and more than 112 countries have signed it, all agreeing to explore peacefully and safely.
Now, the really juicy part for us is buried in Article 9. The language is so specific. It says countries have to avoid harmful contamination of other worlds and prevent adverse changes to our own planet. So right from the start, it was established that this is a two-way street.
And you might be thinking, okay, sure, that's for NASA or other big government agencies. But nope, the treaty is crystal clear. Nations are on the hook for all space activities that come from their country, and that includes all the private companies too. Everybody has to play by the same rulebook.
All right, so a treaty is a fantastic start, but it's a legal document, right? It doesn't tell you how to clean a spacecraft. So, who's the one that translates all that legal speak into a practical, scientific instruction manual?
Well, that massive job falls to a special group called COSPAR. That's the Committee on Space Research. These are the internationally recognized experts, the science brains of the operation. They take all the latest, peer-reviewed science and use it to build the detailed policies that space agencies all over the world follow.
And you gotta understand, this isn't some anonymous, faceless committee. We're talking about a dedicated team of actual scientists, engineers, and legal experts from all over the globe. Each one is appointed by their own space agency or scientific group to come together and figure this stuff out.
Okay, so we've got the law, we've got the scientists, but how does that translate into someone in a clean room with a special wipe? Let's get into the nitty-gritty of how you actually physically clean a spaceship that's heading somewhere like Mars.
First things first, before anyone gets anywhere near that shiny spacecraft hardware, they have to suit up. Why? Because we humans, we're kind of gross. We shed thousands of skin cells and microbes every single minute. These special bunny suits cover a person head to toe to stop any of that from hitching a ride to another planet.
And they build these things in environments that are almost unbelievably clean. I'm talking about hyper-sterile clean rooms, where the air is filtered so intensely that it makes a hospital operating room look kind of dirty. Every single speck of dust is controlled.
But what about the really tough microbes? The little survivors that could make it even in a clean room? Well, for them, you turn up the heat. No, literally. They take entire components of the spacecraft and bake them in these special ovens at super high temperatures for hours and hours to kill off any resilient hitchhikers.
And this cleaning process isn't a one-and-done kind of deal. It's constant. Every single surface is wiped down with special solvents, and then it's swabbed and tested. What they're doing is measuring the bioburden, basically counting how many microbes are left.
As you can see, none of this is just left to chance. These aren't just good ideas. They are incredibly strict, formalized standards. Space agencies like NASA and the European Space Agency have these thick, step-by-step documents that spell out exactly how to clean, test, and sterilize every last bolt before it can fly.
Okay, that is a ton of painstaking work, right? It's expensive, it takes a lot of time. So why? Why does all of this matter so much, especially right now? What's really at stake here?
Well, because our solar system is getting busy. Seriously, it's getting crowded out there. We're not talking about a couple of missions anymore. We have a whole fleet of robotic explorers out there, with more countries and more private companies launching every single year.
And on top of all that, we're starting to aim for places where the stakes are astronomically high. I mean, missions are now targeting these ocean worlds like Jupiter's moon Europa or Saturn's moon Enceladus. These are places where we have really strong evidence of liquid water oceans under all that ice. They're the most likely places to find life beyond Earth.
So you can think of planetary protection as the ultimate leave-no-trace policy. But for the whole solar system, it is absolutely essential. Because just imagine, if we contaminated a place like Europa, we might find life, but then realize, oh wait, that's just some bacteria from a lab in Florida. We would have destroyed our one and only chance to answer that profound question. Are we alone?
And that really leaves us with this final thought. As our technology gets better and better, letting us reach farther into the cosmos, this stops being just a technical challenge. It becomes an ethical one. How we choose to explore and the care we take in doing it is going to define our entire legacy as a spacefaring species.